You ever use an AI tool that just feels like magic? Maybe it translates a menu in a foreign language instantly, or it writes an email that sounds exactly like you would. It's like these things don't just process words, they actually understand language in a way that feels, well, human.
So you've got to wonder, right? How did we get here? How did AI leap from being this clunky, robotic thing to something so incredibly fluent? You'd probably think it was just this slow, gradual improvement over many, many years of research.
But here's the wild part. A huge chunk of that progress, that massive leap forward, can be traced back to one specific moment in time, to a single research paper from 2017 that turned everything we thought we knew about language AI on its head.
See, before 2017, all the AI models that worked with language had this fundamental flaw, a really big one. You could call it a memory problem or a sequential bottleneck, and it was holding the entire field back. Okay, imagine trying to read a really long book, but you can only look at it through a tiny keyhole, seeing just one word at a time. By the time you get to the end of a long paragraph, are you going to remember all the important stuff from the beginning? Probably not. Well, that's exactly the problem older AI models had. These were called recurrent neural networks, or RNNs, and they had to process text sequentially, one single word at a time. The memory of what came first would just get weaker and weaker. So on the left, you've got the old way, the snail's pace, one word after another. It's almost impossible to connect the end of a long sentence with what happened at the start. But the new idea, it was a complete shift in thinking. What if, instead of that keyhole, the model could see every single word in the sentence at the exact same time? That would totally change the game for understanding context.
And that brings us to this team of researchers at Google. They didn't just want to patch up the old system. Nope. They wanted to throw the entire rulebook out the window. Their whole idea was to build a new kind of model that didn't need to go one by one at all.
And the title they gave their paper was, well, it was incredibly bold. You might even say it was a little audacious. They didn't call it Attention is Helpful or An Improvement for Models. No, they called it Attention is All You Need. They were making a massive statement. This one single mechanism could replace the entire foundation of language AI.
And this is what they built, the transformer. Now, I know this diagram looks like a crazy mess of boxes and wires. And yeah, it is. But don't worry about all the little details. The single most important thing to get is that this entire engine was designed for one purpose: to look at all the words in a sentence at the same time in parallel. It was built from the ground up to finally see the whole picture.
So what even is this attention thing that makes it all possible? How can a machine look at a whole mess of words and actually figure out what they mean together? This is where the real genius of the paper comes in. Let's just use a really simple example to see how it works. Take this sentence. The bee landed on the flower because it had nectar. This is a classic little puzzle for a computer. You and I, we know the answer instantly, right? It's the flower. The flower had the nectar. But for a machine, it's just seeing a sequence of words. How does it figure that out? How does it make the connection that it points to flower and not to bee?
Well, that's the job of something called self-attention. For every word it's looking at, in our case the word it, the model also looks at all the other words in the sentence and gives each one a score, basically weighing how relevant it is. The model learns that a word like nectar makes the connection between it and flower mathematically super strong. It's like it's building this invisible web of relationships between all the words.
But it gets even cooler than that. The transformer doesn't just do this once. It uses something they call multi-head attention. The easiest way to think about this is to imagine having like 8 different experts, all reading the same sentence at the same time. Each expert is paying attention to something different. Maybe one is focused on grammar, another is focused on who did what to whom. All together, they build this really rich, layered understanding of what the sentence actually means.
So, look, having a clever idea is one thing, but you have to prove it. The researchers needed to show that their transformer didn't just work in theory, it could blow every other model out of the water.
Okay, so let's look at the hard data. They tested it on the really difficult task of translating English to German. They measure the quality with something called a BLEU score. All you need to know is higher is better. So the absolute best models at the time, a whole group of them working together, got a score of 26.3. The new transformer model, it hit 28.4. And look at the training cost. It did this while being way more efficient.
So that's the number to focus on. A jump of over 2 full points on the BLEU scale.
In the super competitive world of AI research, a leap like that is absolutely monumental. It wasn't just a little bit better, it was a breakthrough. It instantly set a new state of the art.
And this is exactly why it was such a game changer. The Transformer delivered this perfect trifecta. 1, the results were just higher quality. 2, because it did everything at once, in parallel, it was way faster to train. And 3, because it was faster, it was also significantly cheaper to build. I mean, better, faster, and cheaper? That's the holy grail of engineering.
But the story doesn't end there in 2017. That paper wasn't the finish line. It was the starting gun. It basically laid down the railroad tracks for the entire AI landscape we're living in today.
So why does all this matter to you? Well, if you've ever used ChatGPT, you've directly used this paper's legacy. That T in ChatGPT, it stands for, you guessed it, Generative Pre-trained Transformer. The name of this revolutionary architecture is right there at the very heart of the tools we use every day.
And it goes way beyond just ChatGPT. This architecture is now the fundamental engine driving almost every major leap in language AI. We're talking about all the big large language models, the advanced search engines that actually understand what you're asking, the tools that can summarize a long document for you, even coding assistants that help write software. The list goes on and on. They're all built on top of this one idea.
The simple idea that attention is all you need was the key that unlocked this entire modern era of AI. It really makes you wonder, right? What's the next beautifully simple, radical idea out there that's just waiting to change everything all over again?